Hi and welcome to my new video. Apache Spark 3.3.0 is already there, and I have already covered a lot of exciting features of this new version of the framework. And today, in this video and also in the blog post linked in the description of this video, I will focus on Apache Spark structured streaming, which also got a lot of interesting new features. So let's start with something which might be useful for you in unit test, or which was the purpose of the first feature in the benchmark applications. And this first new feature is a new data source called rate per microbatch. So you might be wondering why we need this new data source, and to understand this reason, I will run the code example, starting by the code using previous kinda similar data source, which was the rate data source. So to recall a few details, rate data source has various options, and I will use here only two, which are rows per second, meaning that I will ask Spark rate data source to generate 5 rows per second, and do that for 2 input partitions. So let me run the code and observe what's happening. And this is quite important to see. I'm also using the processing time trigger of 5 seconds to better observe all the changes in the input data. So we have the first microbatch, which is obviously empty, and now we are the first real microbatch with the data, and you can see that although I asked for 5 rows per second, I have much more data in there, which corresponds to like 15 rows, if I'm not mistaken. And it's even worse in the next microbatch, where I do not have 15 but more than 20 input rows. So as you can imagine, if you want to compare the behavior of one feature based on this rate data source, it will not be quite reliable and predictable. And to overcome the issues of the rate data source, Apache Spark 3.3.0 proposes a new data source, which is called rate microbatch. And there are a few differences, quite important for all the benchmarking applications. So the first one is that you can specify the rows per batch. So to set a consistent number of rows generated in each microbatch, the number of partitions doesn't change, and you can also do something more advanced compared to the rate data source. So to specify the start timestamp, so when the data generation will start. And let me run the code to show you these changes. So for me, it will start at 10:25 UTC, which is UTC 12:25 my local time zone. And you can see that it's working correctly each time we are getting 5 input rows. And that's the first feature, quite exciting for the benchmark applications. And the second one is even more exciting because it's not only for the testing purposes or demo, as in my case, but also for your daily work. So just to recall, Apache Spark has this trigger, which is called trigger once. And the trigger once will run this structured streaming job only once and later shut down. The problem with this approach is that if you look at the code, how does it work? Maybe not the best example. So the problem is with the rate limits. Let me just find this fragment. Yeah, that's here. So the one-time trigger will use the single batch executor that when Spark will ask for the data to process in the given microbatch, will simply ignore this default read limit. So for default read limit, you can specify, for example, as in my demo max files per trigger, so the number of files you want to process in each micro batch. And as you can see, Spark will log a warning. It's telling you that it's not supported for this trigger and read all available data. So let me just show this in the code, and to demonstrate this feature, I will generate 6 files and try to process 2 in each micro batch, and do it with the trigger 1. So as you know already, it will ignore my throughput configuration. And you can see that instead of processing only 2 files, Apache Spark structured streaming job took all of the 6 generated files. So obviously it can lead to many problems, mainly with memory, because instead of using cluster sized for this rate throughput limit, Spark will simply take all which remains to process. So imagine a job failed on Friday that you want to restart on Monday. So obviously you have the whole weekend to catch up, and it will unlikely, it will be very probably to fail this reprocessing, this reboot. And to overcome this issue, so Apache Spark 3.3.0 has a new trigger, which is the AvailableNow trigger. And unlike these trigger ones, AvailableNow trigger uses a different executor. And if you take a look how does it work under the hood, you can see that it will run whenever there is something to process. And to illustrate, and of course, thanks to this semantic, it will respect all the rate throughput configuration you set. So in our case, we will have only 2 micro batches processed, and it's also quite exciting. It will not stop at these 2 input files, but it will continue to absorb all the delay accumulated during maybe the shutdown, or maybe during the between two runs. And for our case, you can see that we generated 6 files. 6 files remain to process, and Spark structured streaming with AvailableNow took 2 files for each micro batch as we specified in this configuration. So that was for quite user-facing features. Now there is also another feature which is a bit hidden, but also quite important. And to understand it, I created a bit more complex application, because it uses an arbitrary stateful processing with my rate data source. Because I couldn't use the rate microbatch source, because I will run here Apache Spark 3.3.2.0 versus 3.3.0 and compare the output and the behavior. So the problem with Apache Spark 3.2.0 with RocksDB state store was that for stateful operations were executed not in a good order, because the iterator updating and iterator deleting, removing the old states, expired state, were using the same input data. So in other words, if in your streaming application, if in your microbatch you had one state that was about to expire, but it got a new data from the input, in the previous version, this state would do 2 things. It would update the state and also expire, even though this new data could extend its life cycle, for example, to the next micro batches, to extend its lifespan to the next micro batch. In Spark 3.3.0, it's fixed. So in other words, Spark will update the row and later try to expire the rows on the updated iterator. So in other words, if our state got extended, Spark will simply ignore it in this removal stage. And to understand it, I prepared two modules. Oh, I cannot click on Maven. Okay, I'm good now. So I have two profiles, so these are not modules. I have Spark 3.2 that uses Spark SQL, Spark Kafka, and the same for Spark 3.3.0. And the stateful application, it's also very simple in this logic, because as you can see, I'm printing here for each state, and each state corresponds to nothing more than modulo division by 2. So you can see that I will only have 2 states. I'm printing the watermark, and later when the state doesn't exist or it has expired, I am updating it and extending its expiration time. And otherwise, when the expiration time, when the state expired, I'm simply removing it from the state store, and each time I'm printing something meaningful for the debugging. So let me just maybe add this here. Okay, and now I will run this code in Spark 3.2.0, and let's see together what happens in the console. So you can see that we have already the first, and yes, that's the error I have talked about just before. So we have the watermark group state, which is initializing, it's good, and in the first microbatch you have 2 events, the update plus the expiration. So meaning that you can see that we have some nulls in the output state, but it's mostly because of our stateful function. And that's the problem that is fixed in Spark 3.3.0. So I will run exactly the same code, but with Spark 3.3.0. And logically, if I got this fixed correctly, we should see more consistency in the state operations, meaning that the state will not be updated and expired at the same time. So we have the first microbatch, and yes, you can already see the change regarding our previous execution, because we start once again with state creation, and later we have only this update event. So there is no removal as for Spark 3.2.0. And it's the last interesting feature I wanted to share with you. Maybe it's too high level, and if it's too high level for you, I invite you to the article which is linked in the description of this video, sharing maybe some more code internal details, and also links to the Jira and committers who have done these fixes and improvements to Apache Spark structured streaming 3.3.0. It was Bartosz Konieczny from waitingforcode.com. Thanks for watching.